Hi guys, it's Mrs. Millison. Okay, let's do the check your understanding on page 65. Okay. Here are the data on the highway fuel economy ratings for a sample of 25 model year 2018 Toyota 4Runners tested by the EPA along with the dot plot. So here all of our miles per gallon are out of order, and here they are all nice in order in our dot plot. Okay, so let's find the range of our distribution. So the range is just the max minus the min. So let's see, our max is, looks like 23.123, 23.3, and our min is 21.5. So our range, oops, that's a G. That looks terrible. I'll rewrite it. So 23.3 minus 21.5, and that equals 1.8. 1.8 miles per gallon. So that is my range, 1.8 miles per gallon. Okay, remember, range is a single digit. Okay, you can say it ranges from 23.3 miles per gallon to 21.5 miles per gallon to 23.3 miles per gallon, but the actual range is 1.8 miles per gallon. Okay. Now the mean and standard deviation of the distribution is 22.4. So 22.4 is about there. Okay, makes sense. It's symmetrical, somewhat symmetrical. And standard deviation is 0.363 miles per gallon, respectively. Now, let's interpret the standard deviation. Now, what standard deviation is, it's just the average or the typical distance that the observations are from the mean, okay? So we could say the standard deviation of 0.363 miles per gallon tells us that the highway fuel economy of these 25 model year 2018 Toyota 4Runners typically varies by about 0.363 miles per gallon from the mean miles per gallon of 22.404. So that's just, again, standard deviation is the typical distance that the observations are from the mean, okay? So, you know, sometimes that will be relatively small, which means the observations are very close together towards the mean, and sometimes that standard deviation will be relatively large, which means your data is more spread out away from the mean. Okay, so I wrote that down. Standard deviation of 0.363 miles per gallon tells me that the highway fuel economy of these Toyota 4Runners typically varies by about 0.363 miles per gallon from the mean 22.404 miles per gallon. Okay. All right, number 3, find the interquartile range. Okay, so the interquartile range is just Q3 minus Q1, but we've got to find the median and then Q1 and Q3. We can do it in the dot plot, but we can also do it in our numbers. I'm going to do both, okay? So what we need is we need the interquartile range, IQR, is Q3 minus Q1. So in order to find Q3 and Q1, I need to start with the median. So I'm going to do it both ways. All right, I took this data and I typed it up in order, okay? So we have a sample size of 25. So let's find the median first. So the median will, let's see, 25. What's the middle of 25? I know I got to count 12 and 12 in from, 12 in from both sides. So that'll give me 24. And then that middle one, so the 13th observation will be my median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13th. So there's my median. I can check it from the other side. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. So there's my median. So I actually had a middle, okay? So there's my median. My Q1 is going to be the middle of these 12, and my Q3 is going to be the middle of these 12, okay? I'm not going to use this one because I've already used the median. So let's see. The middle of these 12, well, 12, I know I got to count 6 and 6 in, so there is no exact middle. So I'm going to have to average the 6 from both ends. So 1, 2, 3, 4, 5, 6. So I got to average these two for my Q1. Well, that's easy. To average 22.2 and 22.2, well, that's just 22.2. Okay? And then same thing on the right side with the high values for my Q3. So 1, 2, 3, 4, 5, 6. So I've got to average these two for my Q3. And again, the average of 22.6 and 22.6 is just 22.6. So there's my Q1 and my Q3. So to find my IQR, I'm just going to subtract them. Fold up my page a little bit. So Q3 is 22.6 minus 22.2, so that's 0.4. So 0.4 miles per gallon is my IQR, okay? And again, your interquartile range is just how much the middle 50% of your data varies, okay? Let's look at these on the dot plot as well, okay? Because if you have a dot plot, you don't have the raw data, you can still find your median in Q1 and Q3 on the dot plot. So again, there's 25 dots here to represent the 25 pieces of data. So if I count into the 13th one for the median, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so it's that third one up. There's my median, which is 22.4. And then I count into the 6 from both sides. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I know I'd have to average those two for my Q1, which I would get 22.2. Okay? And then same thing for Q3. There's my median. I want to try not to write in the book. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So I would have to average these two for my Q3, which again is 22.6. Okay? So if you're given a dot plot, you can find your median Q1 and Q3s just by counting, okay? If you have your data, sometimes it's a little easier to put your data in order, but whatever you prefer, you're gonna get the same answer. Okay. Now, which measure of variability would you choose to describe this distribution? Okay, let's do a quick description. I would say the shape of the distribution of highway fuel economies is roughly symmetrical. It's got a single peak at about 22.4 miles per gallon, appears to have possibly two outliers, a low and a high outlier. We've already been told the mean is 22.4, and we know our median is 22.4. Okay, so that would be our center. We figured out our range and our IQR, and we have our standard deviation for our variability. So which measure of variability would we choose? Now, range is always a good one, okay, max minus the min, but since this has some big outliers or possible outliers, we should probably use the interquartile range, okay, to describe the variability, okay? And why? Because again, median and interquartile range aren't impacted by these extreme values, okay? Now, if those two values were gone, and again, don't delete observations unless you're told to, and our distribution is symmetrical, I would probably use my standard deviation to describe variability and spread, okay? So really, outliers play a big part in determining which measure of variability to use, which measurement of spread to use, and shape as well, okay? Let's see, I wrote this down. Range is always a good measure of variability or spread, regardless of shape, but since the distribution of fuel economy has outliers, we should use IQR to describe its variability, since IQR and median are resistant to those extreme values, okay? Mean and standard deviation will be greatly impacted by extreme values. Okay, hope this was helpful. See you next time.